So welcome to quarter 2, 1.1. There's a lot of vocabulary in this section. So we're going to be dealing with rational functions. So we're going to start putting polynomials in fraction form. So our numerator and denominator are polynomials. And when we graph those, we still have x and y intercepts. We're still crossing at the x-axis and the y-axis. So for this graph, look at your x-axis. Where do we cross? That's an x-intercept. And then you would look at the y-axis. Where do you cross? That's a y-intercept. Okay, those are normal. But we have these things called asymptotes. And these are vertical or horizontal lines where the graph cannot cross. And that's because when we get fractions, things get undefined when we're talking about fractions. And that is because you cannot have a 0 on the denominator of a fraction. It just messes with stuff. Okay, so a vertical asymptote is a line that's vertical up and down, and the values correspond to the zeros of the denominator. So for this function here, if I look at the denominator, x minus 3, and set it equal to 0, and solve, this is saying if x equals 3. So look at this. If this x equals 3, my denominator is going to be 0. That's bad, right? So at x equals 3 on our graph, there's this line where the graph cannot cross. That's called an asymptote. And we get the same thing horizontally. And these ones are a little more tricky because there's rules. So that's what this graphic is. Horizontal asymptotes, there's rules that go here. So, and that's based on the degrees of the numerator and degrees of the denominator. And degree is look at the exponent. That's what degree means. Okay, so if the exponent is the same, you look at the coefficients. If the exponent on the bottom is more, the asymptote's y equals 0. If the exponent on the top is greater, then there's not even a horizontal asymptote. So for our example, we have x plus 3, x minus 3. The degree on these x's is invisible. This is degree 1. This is degree 1. Since they're the same, you divide the coefficients. So this is 1x over 1x. Our asymptote is y equals 1 over 1, or just y equals 1. So right here, this is our horizontal asymptote. And you can kind of see the lines curving away from it. Okay, the lines will never, ever cross that. And then this example does not have a hole in the graph, but we're going to look at some that do. A hole is another place where the function's undefined. And that's where a numerator and a denominator cancel out. They're the same. So here's an equation, x plus 2, x minus 4 divided by x minus 4. Because these are the same, they would cross each other out. That's an undefined value on the graph. So we call it a hole. So x equals 4. The numerator and denominator have the same factor. So the hole is setting that factor equal to 0 and solving. So there's a hole at that value. So if we're going along on a graph, it's literally a hole. It's undefined at that spot. The graph just jumps over it, and then it continues. And we'll see some of those. But for we're it asks you for a hole, you have to remember how to factor. And that's from quarter 1. So we're going to be reviewing factoring as well for this section.